Right, what I want to do today is look at cubic graphs. So let's just start with one and we'll have a look and see what that sort of looks like. So I'll put one in, I'll go x plus 1. It's quite nice with Desmos, you can see it sort of drawing as we go. And we'll go x minus 1. Oh, that's not what we want. X. What's happening there? Okay, that's misbehaving. Now it's better. X minus 1. And that's parabola now, right? Now we're going to turn that into a cubic. So let's go x minus 3. All right, so what we've got there is a cubic. Okay, so it looks different from a parabola in that parabola, sort of your standard parabola starts high and finishes high, whereas the cubic, you should notice, sort of starts low on the left-hand side and sort of finishes high on the right, or at least this one does. The other thing to note there is we can see where the x-intercepts are. So there's one at -1, which corresponds to this one over here. There's one at +1, which actually corresponds to that one here. And there's one at 3, which corresponds there. So you can see we can change these things around. If I move that to a 2, you can see that that's further out. And you can also see that that tends to go a bit higher. Same with this. If I move this one out, it'll go higher still. Off the size of the graph, we can bring that down. We can have a look at it. You can just play around with these things, and it's a good idea for you when you get to have a go at it, that you do that yourself as well. And I've just changed that to 4. So we're just getting different looking graphs as we change those numbers. Now, with a parabola, we were always required to work out the vertex. Now, not the case with the cubic, because there's not the same symmetry that's there. Sometimes there's rotational symmetry, but there's not the line symmetry that there is nicely with that. So when we're sketching it, which we'll do, is we're not really that concerned with where the vertices are. What we are concerned about is the x-intercept and the y-intercept. And you can see the y-intercept is up here. So you can look at that and you can see that the y-intercept is 3. And the reason for that is that we just multiply these numbers together. So remember, the y-intercept occurs when x is equal to 0. So I get 1 times -3, or times -1 times -3. And that gives me +3. Let's do another one. Okay, so I'll put another parabola on. And I've got y equals, and this I'm going to start with an x. So there's you can see the blue line occurring there. And I'll keep the rest sort of similar. I'll go x minus 1, and we'll go x minus 2. What a silly x. Let's get rid of that. Put the caps lock button. All right, if we look at this one, I'll just turn that one off there so that we're not confused, and we'll zoom in a little bit. So this one here, because it's x out on its own, all right, it passes through this point here, x is equal to 0. Very convenient. So it passes through the origin, which means also that the y-intercept is 0. And you can see that that's true because it doesn't intercept anywhere along here. It passes through 0. So we can see that it intersects at x equals 1. When this is equal to 0, remember we set y is equal to 0 to find the x-intercept. And 2. There's that point there, and then 0. And of course, 0 times -1 times -2 is 0. Let's make this just a little different. And now notice I said that they start low and then finish high, and they do, except if we put a negative in front. Now, if I multiply this whole thing out, I will end up with a negative x cubed. So if the x cubed is negative, we get this kind of shape. So it starts high and finishes low. And we've sort of, if you could just pull the thing straight, you can see that we'd have a negative gradient. And we call this a negative tending cubic. So a negative tending cubic has the highest power, in other words, the x cubed power, with a negative coefficient. So it could be negative 2x cubed or negative x cubed. Well, it could be 7 minus x cubed. But it's negative x cubed somewhere along the line to get that. If I remove that, you can see it flips it back again. That's a nice thing to do, play around with that. And I think, you need to go into Desmos and play around with these things yourself as well. Let's take this one because this is a nice kind of parabola to muck around with. So I'm going to copy it, parabola, cubic. And I'll take this one out. And instead, I'm going to square this one over here. Okay, and we'll just turn that one off for a moment and have a look and see what that does. So if I expanded that out, by the way, I could have written that one if I paste it again and gone x minus 2. See that? X minus 2, x minus 2. It's the same, eh? All right. So x minus 2 squared is the same as the one below there where I've got that x minus 2 twice. So we don't need that one. We'll go back and look at the green thing. Now, if you look at the intersection, so it passes through 0 as we'd expect because of the x sitting out on its own. But there's not 2 intercepts for this, is there? It's sort of, well, it is. It's kind of 2 and 2. There it is there. So it intersects the x-axis at 2 and then kind of at 2 again. But notice that it just touches. And so the rule for this is that if it's a square there, then the x-intercept at this point, which is 2, it touches at that point and then goes back up rather than passing through the line underneath. If I take that square out, and instead write out, delete, there's a parabola again. But if I put the square on the x, can you see it does the same thing? So look at where it touches that point there, 0, 0, but it just touches it, doesn't pass through. See, now it clearly goes right through here, right? When it's just by itself, x minus 2 goes right through. When it's got the square on it, we've just got this over here. We can do that with these ones over here as well. If I take this out and turn it back on again, we should end up with, oh, that's not good. I want a bracket. Yeah, that's better. Now, if I put a square on that, you can see the same thing is happening. Notice the square is on the x plus 1. Therefore, at minus 1, it just touches at that point. But at 3, it passes right through. So that's the difference. If the square's on it, it passes right through. If it's not on it, then it doesn't. And if I move the square, let's get rid of it completely and put it over here instead. Then now we've got it touching, behave. We've got it touching over here. Notice it doesn't pass through, but it does pass through -1. Worth a while just having a look at this number here, the y-intercept again. Remember, it's -3 times -3 is 9, and 9 times 1 is 9, and so it's cutting through over there. What you need to do is you need to get Desmos and do the same thing that I've just done. Have a play around and see if you can get different cubics, get some negative ones. This one, by the way, if I just put a negative in front of it, we'll flip it over. Okay, there it is there. Play around with some of those squares. I know some of you will want to try some other things as well. But at the moment, just stick with cubics and learn what you can about each one of these.